Bismillahirrahmanirrahim. Assalamu alaikum, student.
Walaikum salam.
So last time we were studying this chapter number 5 and we have solved the problems of chapter number 5 in different situations. So you remember that we have discussed a lot of situations. So in one situation, you remember that the bodies are hanging like this one, or the body is hanging like this one, or some other way. So these are the situations in which the bodies are hanged like this or like this. So then we have discussed the situation in which the bodies move over the pulley. So this is the pulley and like this. And then one body is moving horizontally and the other body is moving vertically. Then we have discussed the situation in which the block is placed on a horizontal surface and the force is acting parallel, or the force is acting in this way, or the force is acting in this way, like this one, or in this way. We have discussed all these situations. And then we have discussed that if the body is placed on an inclined plane, the force is acting like this one, or force is acting like this one, or force is acting like this one. Or maybe the force is acting like this one. This is one body. And then we have discussed if two bodies are placed like this and force is acting in this way or in this way, you can find the acceleration or the forces. Okay. After this, the other situation which we have discussed, that if two bodies are connected with the string, or more than two bodies are connected with the string, like this one, you can solve these problems. I have discussed with you. Now the last but not the least situation is this one. If one block is here and over it another block, this is called block on block. So in this situation, we want to find the frictional force or the acceleration or the net force. So in this problem, if this is M1 and M2, first we have to decide that either the both bodies move together or not. But normally at your level, in your problems, they are giving that the both bodies are moving together. If both bodies are moving together, how we can control the situation? And if both bodies are not moving together, then how we can control that situation? So if the force is acting here and the body, this is the frictionless surface and here is a friction, then how we can control the situation? So the first question is that if both bodies are moving, it means they are moving with the same acceleration. So to find the same acceleration, what we will do? We will divide the force divided by the sum of these masses, M1 plus M2. So in this way, you can find the acceleration. I'm taking another example. Suppose this is a block and it is 6 kg, and this is a block, it is 4 kg, and the force is acting here 50 Newton. Now the question is either the both blocks are moving together or not. So to check this situation, first what we will do, we will find the acceleration first. So F over total mass. So F is 50 divided by the total mass is 10, and acceleration will be 5 meters per second square. So this is the value of acceleration with which the both blocks are moving. So our force is 50 Newton. Now you will multiply this acceleration with this mass. So mass is 6 multiplied by acceleration is 5. This is the force, and this answer is 30 Newton. So if our answer is 30 Newton less than the 50 Newton, so it means both blocks will move together. Both blocks will move together. But if this force is more than this one, then they will move separate. This is very important. Okay. The other important thing is this one. If the two blocks are moving together, either the force is acting here, or in the second case, or the force is acting here, either here or here. They are moving together. Then remember, the direction of the frictional force will be in the right hand side. Right hand side means the frictional force will be this one and this one. But here maybe you cannot do experiment in a real life. So here you can do the experiment in a real life. If you pull this mass rapidly, quickly, then this mass will go where? This mass will go in this direction. The frictional force is always opposite to the relative motion. Relative motion is towards left. The frictional force will be towards right. So remember, if both blocks are moving together, their direction of friction will be towards right hand side. This is very important point which I want to give you. Okay, after this, now I'm solving two problems from your this test bank, and see if we have this block, and this block is 2m, and another block it is m. The force is acting here 1.2 Newton, and m value is 1 kg. It is given. The question is, find the frictional force between the two blocks, and this surface is frictionless. So it means here the mu value is 0. But here mu value is not given. Mu value is not given. You just find the friction, F. So to find the F value between the two blocks, what you will do? First find the acceleration, combined acceleration of m and m2, because both bodies are moving with the same acceleration. So A is equal to 1.2 divided by, this is the force, 1.2 divided by the total mass. So m is equal to 1 kg. Here m is equal to 1. Here m is equal to 2 kg. So the total mass is 3 kg. So this is equal to 0.4 meter per second square. So this is a combined acceleration. Now you want to apply the equation to find this value F. Okay. So here you can see that F is in the right direction. F minus this value F. This value F is what? This value F is that value which is opposing between m and 2m, and surely it will be in this direction. So the frictional force between the two masses, in this way and in this way, they will make a pair and they obey the Newton's third law. So we will write F, and this is equal to m2, 2 into A is 0.4. So I write this equation in this way, minus F is equal to 2m into A. So m is equal to 1 actually here. So you can solve this equation. 1.2 minus F is equal to 0.8. So 1.2 minus 0.8 is equal to F. So F is equal to 0.4. So 0.4 is the answer. But the question is, this frictional force is 0.4 in the right direction or in the left direction. So remember, I already explained that if two blocks are moving together, then the frictional force will always be in the right hand side. Mean this is the frictional force in this side. Although the opposite force is applying here, but frictional force is this side. Okay, one question is this. The second question, now we are taking a block of 3m and a block of 2m. And here again, m is equal to 1 kg. And the force is acting here, not here, is upper. And this F is equal to 1.2 Newton. Now the question is, find the frictional force between the two blocks. Here it is frictionless. So the frictional force is 0, or mu value is 0 here. Here is some mu value, but we don't know the mu value. We will solve it with the other style. A is equal to F over total mass. So F is 1.2 divided by the total mass 3 plus 2 is 5. This is equal to 0.24 meter per second square. This is the acceleration. Now you want to find the frictional force between the two masses. So how you can find F minus F is equal to M into A. So F minus F is equal to M. So M is what? Where the force is applying to M. So 2 into 1 into A is 0.24. So F is equal to what? 1.2 minus F is equal to, this is 0.48. So this implies that F is equal to 1.2 minus 0.48, and this is 0.72 Newton. Now the question is again, where will be the direction of this frictional force? They are moving together. They are moving together. So the direction of frictional force will be right hand side, not left side. Remember this one. This is very important. Okay. After this, if we have, suppose, I just want to tell you, if we have, suppose, 3 blocks, and 3 blocks are stick together like this, one block and the second block and third block, and these blocks are put on the surface, and the force is applying here. Okay, this is A block, this is B block, this is C block, and their mass is M, same mass. And this surface is frictionless, no friction. But there is a friction between block B and C, block A and D. And that coefficient of friction is same. So how you can write the equation? So the friction force between C and floor, between C and floor is 0, because there is no friction here, mu value is 0. Here is some value, but we don't know the value. We just write the equation. So between B and C, I'm writing between B and C. So between B and C, first find the acceleration. So acceleration will be what? Force divided by total mass. Total mass is what? 3m. So what is the frictional force between B and C? You can find the frictional force between B and C. The mass is 2m multiplied by F over 3m. This is m into E. So m is 2m. So when you cancel this one, you will get 2F over 3. Okay. After this one, the frictional force between A and B, between A and B is what? So F of AB is equal to MA between A and B. So when you are taking B, you have a down is M. Okay. So when you are taking A and B, so the force of frictional only will be the between A and acceleration is F over 3m. So this is also m cancel. So this will be F over 3. So in this way, you can check and see the frictional forces between the two bodies. Okay. After this, now I want to discuss with you some other problems. Okay, let's see. Just wait. I on the slides and then I will tell. So here you can see so last time we have discussed all these types of problems we have solved, and now I want to solve some other problems. These types of problems I have already discussed with you. And this problem I have discussed recently, and this problem I have discussed with you. Now see this problem. So in this problem, what we will do? To solve this problem, two blocks connected by a string are pulled across a horizontal surface by a force applied to one of the block. The coefficient of kinetic friction. So kinetic friction is the friction when the body is moving. Between the blocks and the surface is 0.25. So here is the surface. 0.25. This is the value of mu. K, kinetic friction. If each block has an acceleration of, so the block is moving in this way and the acceleration is 2 meters per second square. To the right, what is the magnitude of F to the applied force? So we need this F value. So what we will do? We will find the components, this component and this value is what? F cos of 60, and this is F sine of 60. Here is M1G, and here is the N1 normal reaction. Here is M2G, and here is the normal reaction N2. So you can see that the two bodies are connected with a string, and the tension it is moving in this side, right side. So this is the tension direction. I'm taking this direction of tension. So if I consider this block only, then T minus M1G, okay, T minus not a M1G, T minus mu K into M1G, because the frictional force is this side. This is F of K. So F of K, I am writing mu K M1G is equal to M1A. So now you can solve it, write the equation in this form, okay. The other equation for this block, for this 3 kg block, you can write the equation that F cos of 60 in the right side minus F cos of 60 minus mu K into N is equal to M2A. Now here the question is n. What is the value of n? N is important here. So n mean here n2. So n2 is upward, f sine theta is upward. N2 plus f sine 60 is upward, is equal to downward. Downward is m2g. So n2 is equal to m2g minus f sine of 60. So this is the value of n2. Now what we will do, we will put the value of n2 in this equation. And this is m2g minus f sine of 60 is equal to m2a. So from this equation, its acceleration is given already. Acceleration value is 2 meter per second square is given. So what you will do, you will solve it for f. So f cos of theta minus mu k m2g plus mu k f sine of 60 is equal to m2a. So you can solve it f cos of theta plus mu k f sine of 60 is equal to mu k m2g plus m2a. Now we can make common f, and cos of theta plus mu k sine of 60 is equal to mu k m2g plus m2a, and f is equal to this value divided by this value. So mu k m2g plus m2a divided by cos of theta plus mu k sine of 60. So you have a mu k value, you have a m2 value, g value, a value, every values we have. Okay. So we can solve it. So cos theta is actually here 60 degree. Okay. So you can solve it and find the value of f. So your f value will be around 25 Newton. So in this way, you can solve this problem. So in this problem, basically the tension is also involved and this component of forces are also involved. That's why it is a little tricky and a little bit complicated. Okay. After this, now we want to solve this problem. In this problem, you can see a 4 kg block rests between the floor. This is the floor, and a 3 kg block as shown in the figure. This 3 kg is over 4 kg. The 3 kg block is tied to a wall of a horizontal rope. This is the horizontal rope or string. So the tension is here, like this one. If the coefficient of static friction is 0.8 between each pair, so here is the static friction of surfaces in contact, what horizontal force must be applied to the 4 kg block to move it. So here you can see that we have 3 kg. So mu s value is 0.8. Okay. This is 0.8. So first find the fs value. Fs mean the static friction value, 0.8 into 3 into 9.8 due to this block. So fs is equal to what? This is equal to 23.54. So this is one value we have found from here. So from here, you can also find the acceleration, and that acceleration is called maximum acceleration because f of x is equal to ma of s, and this is equal to 23.54. So you can divide it by 23.54 divided by 3. So you will get 7.84 meter per second square. So acceleration we have found. Now we want to write the equation for this force because we need this force. So F minus this frictional force, which is opposite to this one, 23.54 is equal to M into A. So here M is what? M is actually the total mass. because the total mass is moving. So M is the total mass into A. Now you can solve it. F is equal to 23.54 plus MT is 7 into A is 7.84. So when you solve and add this one, you will get the value of 78.47 Newton. So here this is the answer. Okay. After this, then we have this problem. In this problem, you can see that there is one block and another is over another block. So how to solve this one? So here you can see that mass of A is 25 kg is given, this one, and C is 6 kg is given. The coefficient of static friction between block A and C mean here. This is the coefficient of static friction. This is 0.23. Block B is suspended from this one, and it is MB block. This is MA, this is MC, and the system is subsequently released from rest. Find the maximum value for the block mass of the block B. So we want to find this one. When the system is let go, C block doesn't slide on A. So when it is moving in this way and this is moving in this right direction, the C block is not sliding, mean it is stuck with A. So it means we have not applying enough force in this direction that C is sliding. So C is just over it. So it means this frictional force should be sufficient. So what we will do to solve this problem, first see the MBG weight will be downward and the tension force will be upward. Here the tension is this one. Now to solve this one, first write the equations for this side. This side equation is what? MBG minus T is equal to MB into A. So it is going down. MBG minus T is equal to net force MB into A. And what is the equation for this T? So T is equal to, because it is moving combinedly, so we will add the masses MA plus MC into A. So we have these two equations. From these two equations, add the equations. When you add the equation, this tension will eliminate and we can find that MBG is equal to, add this one, MA plus MB plus MC multiplied by A. So this is our A value. So from here, you know that body C is over body A with some frictional force. So that frictional force is actually MC into A. So A is what? Fs is equal to MC into A is equal to, so we can write this value, A is mu into mu S into G. So this is MC. Okay. So this MC will cancel and A value will be what? Actually, I want to write the A value in terms of mu S into G. You can understand this one. So A value is mu S into G. How I get this value? I know that Fs is equal to mu S into N. Okay. And Fs is equal to mu S into N is what? Mg. Okay. So here you can write Ma. So this M will cancel with this M and A will be mu S into G. So that's why I have written like this one. No, you have A value is mu S into G. Now put this A value here. So MB into G is equal to MA plus MB plus MC into mu S into G. Now we have mu B, mu S into G, this one and this one and this one multiply. So what you will do? We need MB. To find MB, what we will do? MB into G minus MB into mu S into G is equal to MA plus MC into mu S into G. So I just separate the MB mu S G with MB G because I need MB. So MB will be what? So MB will be common G minus mu S into G is equal to MA plus MC into mu S into G. So you divide this one and find the value of MB. So it is MA plus MC into mu S into G divided by G minus mu S into G. So you can solve, you have A value, you have C value, you have mu S, G, every value you have. So when you put the value and solve it, you will get the answer of this MB. So in this way, you can solve it. This is a little tedious problem. Okay. So see this problem. I am not solving this one because I'm not confirming sure the answer of this one. But I just want to tell you, if you have 3 blocks, then how you can define this write the equations of these 3 blocks. I just want to write the equations of these 3 blocks. Let's see. So we have this 3 block system. So in this 3 block system, in this question, he is saying that this floor is frictionless. So between C and this floor, between C and floor, you know that this is mu is equal to 0. So if mu is equal to 0, then the frictional force will be 0. So between B and C, here is a friction, here is a friction. Okay. So between B and C, first find the acceleration, F over 3m. Always first find acceleration. So between B and C, so we have ms and ms. We have 2 masses. So to find the 2 masses, F of BC is equal to what? So this is 2m multiplied by F over 3m. You can solve it and get the answer of 2F over 3. For AB, so remember for AB, when you have the upper mass and the lower mass, then you will get that m into F over 3m. So cancel this one. This is F over 3. So your answer will be F over 3. So here maybe the answer is this one, but I'm not sure that this answer is correct or not. Okay. After this, this is the same problem which I have solved before. Now I want to solve this problem, and this is the problem which is also important, especially in case of this Newton's third law of motion. So in this problem, you can see a 30 kg is pushed up. It is pushing up, okay, by a wall of a force P that makes a 50-degree angle. So this is the angle of 50 degree. So make the component first. This is component. This is component. So this is P sine of 50. This is P cos of 50. With the horizontal, the coefficient of static friction between the block and the wall is static friction is 0.25. Static mean it is stable, 0.250. Determine the possible value for the magnitude of P. So this is the P. So you have, this is the N. Normal is always perpendicular to the surface. So this is N. And this N is equal to what? This is in this direction and this is in this direction. So N is equal to P cos of 50. One equation is this one. The other equation we want to write, mg is downward. this block is going to move down, the kinetic friction, the friction will be upward. Okay. Now write the equation. This is upward. This is upward. So it means P sine of 50 plus F is equal to mg. This is our equation. And P sine of 50 plus F is what? Mu k into n. And this is equal to mg. Now you can solve it. P sine of 50 plus mu k into n. N value is what? P cos of 50 is equal to mg. Now you can solve it for P. So common is P. Inside is sine 50 plus mu k cos of 50 is equal to mg. Now you can find the value of P. Mg divided by sine of 50 plus mu k cos of 50. Now we have m value, we know g value, sine 50 we know, mu k is given, and cos 50 is also, you know, and putting the value and solve it and get the answer. So this is the problem. This is the last problem which I want to discuss with you. So in this way, I have discussed with you different situations of the problems. So you should solve the problem yourself, especially for the inclined plane, especially for the connected bodies, and especially for the blocks over the block. Okay. And then the hanging bodies. Okay. And the bodies are on the horizontal surface. The force is applying here or here or here. So all these situations you should consider and solve the problems and make the practice. So this is the total lecture today, and inshallah next lecture I will start chapter number 6. So if you don't have any question, see you in the next lecture.
Thank you.
Okay, Assalamu alaikum.